ऑन करना होगा। गुड मॉर्निंग एवरीवन, आवाज आ रही है? सो आप सभी लोगों का बहुत बहुत स्वागत है एग्जामपुर आईएएस के इंग्लिश मीडियम चैनल पर। सो वेलकम टू यू ऑल ऑन एग्जामपुर आईएएस इंग्लिश मीडियम। और टुडे वी आर गोइंग टू स्टार्ट physical geography section in which first of all I will introduce myself. My name is Aman Sinha. I am taking classes for IAS from the last 10 years. Okay, और ये जो मुझे अभी सेक्शन दिया गया है क्रैश कोर्स के लिए for the 40 days for the upcoming UPSC Prelims 2022. So I hope कि कुछ बेहतर करके जाएंगे इतने वेरी लेस स्पैन ऑफ टाइम। ओके, सो एक बार फिर से आप सभी का बहुत बहुत वेलकम है। जिग्नेशा, उर्वशी, सौम्या, ओके, ये बच्चे भी जुड़े हैं यहाँ पे, बहुआ बिहार का, मृदुल राज, पीहू। एज ऑफ माई थॉट्स की कुछ बच्चे शायद पुराने भी हैं जो मुझे जानते भी होंगे और कुछ बच्चे जो नहीं जान रहे होंगे, धीरे जान जाइएगा। We will focus on concept clarity based classes and today we are going to start a climatology section in which the very first I will give you an idea about the atmosphere कि कैसे atmosphere से questions arise किया जाता है। prelims as well as mains में भी एक क्वेश्चन मैंने आपके लिए डिजाइन किया है कि कैसे मेंस में क्वेश्चन आ जाते हैं, बट अभी फिलहाल हम लोग फोकस करेंगे सिर्फ prelims पर। ओके, सारे जो यहाँ पर जो कंटेंट जो आपके होंगे वो इंग्लिश मीडियम में होने हैं, सारा का सारा। कुछ क्लासेस जो डिजाइन किया गया हुआ है ये प्रॉपर इंग्लिश मीडियम के लिए है, तो उसी तरीके से ये चलेगा कोर्स आपका। सारे आपके नोट्स जो बनेंगे वो भी इंग्लिश मीडियम में ही टोटल बन जाएंगे, ठीक है। सौम्या शेखर जी फ्रॉम द सार्थक बैच, वेरी नाइस। सुमित तिवारी, ओके, इफ आई एम नॉट रॉन्ग, सुमित यू आर आल्सो फ्रॉम द सार्थक बैच। सुभाषिनी सूर्यवंशी फ्रॉम द एमपी चैनल, पीहू फ्रॉम द आईएएस पीसीएस, am I right? Okay, so physical geography part we are going to start on this channel. Prelims we are focusing on the prelims 2022. Okay, so before to go for the main part, I want to introduce this poster, मसाल बैच। हाँ, मसाल बैच ये दिया गया हुआ है, included the 25 exams, 25 एग्जाम के कोर्सेज को इसमें दिया गया हुआ है। एग्जामपुर ऑफिशियल एप्लीकेशन पर ये है। अगर आप में से आपके फ्रेंड्स में, आपके भाई बहन में, आपके रिलेटिव्स में कोई भी अगर इन सब एग्जाम्स की तैयारी कर रहे हो, एसएससी, दिल्ली पुलिस, यूपी पुलिस, यूपी ट्रिपल एससी, रेलवे, सीएटी, तो आप उनको सजेस्ट कर सकते हैं। बहुत ही ऑसम बैच है, 2 साल की वैलिडिटी है, ये ध्यान में रखिएगा। ओके, सो आइए आज जो हम लोग टॉपिक लेने वाले हैं दैट इज द एटमॉस्फेयर। एंड यू कैन सी अबाउट द एटमॉस्फेयर, फर्स्ट ऑफ ऑल वी हैव टू गेदर द नॉलेज अबाउट द डेफिनेशन। What is the definition of atmosphere? How can we correlate the atmosphere with some other sphere like a biosphere, like a lithosphere, like a hydrosphere? So there is another one that is the atmosphere. Without it, we can't survive. There can't be living things present on Earth's surface. So second one is the composition of gases, in which we will learn what about the composition of several gases like nitrogen, oxygen, their percentage, and also included the aerosols, dust particles as a solid particles, and water vapor. Questions arise from those regions also. Then we will move for the structure of atmosphere and the stratification as well. Like you can see the structure of atmosphere, in which you can see the 5 layers of atmosphere, the lower layer, then the middle level, and the upper layer. इस तरह से questions बनते हैं। And the last point, the significance of atmosphere also we have to learn. Sometimes the questions arise from those regions also. Okay, so again one more time welcome to you all. So now we are going to start our class with the definition. First of all we have to get the knowledge about the definition. What is atmosphere? So you can see here, first of all, here it is Earth, and it is surrounded by gaseous molecules, and also in the lower part you can see the dust particles and the water vapor, That means ki it includes the teeny particles of gases and dust as well as. Okay, here you can see other ki is some gases having a taste or not, or it's having a color or not, is some gases having a odor, or this one is a opaque or a transparent. So you can see the atmosphere is a mixture of gases. We can't say that it is some other phenomenon. It is just a mixture of gases. Okay. So first of all, we have seen that it is mixture of gases, but what kind of gases? So here you can see the gases are the colorless. Like you haven't seen a color of nitrogen or oxygen. अगर ऐसा हो जाता तो आप जिधर ऑक्सीजन का कलर होता है उसकी ओर भाग रहे होते, मुझे ऑक्सीजन इनहेल करना, नाइट्रोजन छोड़ना, ऐसा नहीं होता. We inhale air, not the oxygen, but our body accept only the oxygen and exhales rest of the amount of gases. So first of all, the gases are colorless. Okay. Next one. These are also odorless. Take. These are also odorless. So the gases are colorless, odorless, tasteless also. We can't have a feelings of taste of such gases. So you can mention here tasteless. And also these are transparent body. So also you can make one more point. These gases are what? Are transparent. Okay. And it surrounds whole around the earth till 1000 kilometers. Now you can see the gases covered whole around the earth. And how much kilometer? That is the 1000 kilometer. It can extend till 10,000 kilometer. It can extend till 10,000 kilometer. But regarding the exam, we'll learn it till the 1000 kilometer. Okay. So, and why such gases are present on this earth? Why? So it's just because of gravitational force. It's just because of gravitational force. It is bounded by Earth's surface. Are you getting? So getting or not? So our definitions comes atmosphere is mixture of colorless, tasteless, odorless and transparent gases and transparent gases इसी में एक पॉइंट और जोड़ दीजिए ट्रांसपेरेंट गैसेस एंड teeny particles of solid materials और dust particles आप यहां पर कर सकते हैं teeny particles of solid materials और dust particles which envelops whole around the earth, which envelops whole around the earth till 1000 kilometer due to gravitational force of the earth, due to gravitational force of the earth. So that is the definition of atmosphere. We can see here the atmosphere is mixture. अब यहाँ पर बार करते हैं, जरा सा देखिए कि this one is mixture. So atmosphere is a mixture of colorless, tasteless, odorless and transparent gases, including tiny particles of solid materials. ठीक है, इंक्लूडिंग कर सकते हैं यहाँ पर, एंड की जगह पर आप चाहे तो इंक्लूडिंग कर सकते हैं वर्ड यहाँ पर, इंक्लूडिंग tiny particles of solid materials और dust particles which envelops. अब ध्यान रखिए ये envelops के रूप में आपके सामने में है, जैसे होता है ना कि envelops होते हैं, इसमें आप पेंसिल से रख के देते हैं, उस तरह से पूरा का पूरा घेरे हुए चारों तरफ से, envelops whole around the earth till 1000 kilometer due to gravitational force of the earth. So 2 or 3 points arise from this definition. Okay. Right now my classes is running in Sarthak batch Soumya. You are there also. So let's see क्या रहता है, करेंगे कुछ ना कुछ तो बेहतर. ठीक है, एक बार सभी लोग जो भी यहाँ क्लास कर रहे हैं, तो जो भी बच्चे जो आपकी जानकारी में क्लासेस करते होंगे उनको आप जरूर ये बता सकते हैं कि वी हैव स्टार्टेड आवर क्रैश कोर्स, वी आर गोइंग टू एक्सप्लेन, और कंसेप्ट बेस्ड क्लासेस हम लोग यहाँ भी प्रोवाइड करेंगे. सो मोस्ट प्रोबेबली कोशिश होगी कि एक बेहतर क्लास आप लोगों के साथ में लेकर चले. सो एज ऑफ माय थॉट कि यू ऑल आर गेटिंग व्हाट अबाउट द डेफिनेशन एंड कमिंग फॉर द नेक्स्ट. ये सम पॉइंट्स है जिसको आपको ध्यान में रखने की जरूरत है. यू हैव टू कंसर्न आल्सो अबाउट दिस. सेम थिंग इज देयर. Our planet Earth is enveloped by a deep blanket of gases extending several thousands of kilometers above its surface. This gaseous cover of the Earth is known as the atmosphere. Okay, and like you can see, just I have explained, like a land lithosphere and a water hydrosphere, the atmosphere is also an integral part of the Earth, and it is held in place by the gravitational influence of the Earth. There is one more sphere, that is we call to say the narrow region of the atmosphere and the lithosphere and the hydrosphere, that is so called the biosphere. The fourth one is the biosphere. ठीक है, fourth one is the biosphere. Okay, and that is the narrow region of the several these three regions. Okay, come for the next. Now we are coming for the composition of gases. Composition of gases. So here you can see the nitrogen, the percentage of nitrogen and oxygen and the argon and the carbon dioxide. These four elements are a heavier gases. Heavier gases. So these gases are found on the lower layer of atmosphere, and that's why the 97% part of the atmosphere, 97% part of the atmosphere lies within 29 kilometer from Earth's surface. So this is the also we have to make down. 97% part of the atmosphere lies within the 29 kilometer from the Earth's surface, is just because these heavier gases are found in the near or lower layer of the atmosphere. And whatever the percentage, the nitrogen having a 78.08%, oxygen 20.95%, argon 0.93%, carbon dioxide is 0.036%. Right now you can mention here 0.04%. Right now. And the very less amount of percentage of several gases are also present in the atmosphere. You can see the neon, helium, krypton, methane, xenon, hydrogen is available. Okay, so these are the light gases. These are the light gases. I want to explain one more thing here, that is, like you see, you have read the inert gases. Inert gases or a noble gases. Noble gases. These gases are light gases. If question arises कि out of 6 noble gases, which one is heavier? So here you can see the neon, radon, xenon, krypton, and also one more, here it is the argon. So these are the light gases, and out of these, argon is heavier gas. Okay, argon is heavier gas exceptionally. Exceptionally, argon is heavier gas. You have to remember it also. Argon is heavier gas. And some other light gases are, you can see the hydrogen and the helium. These are also the light gases you can mention here. Okay. Clear है सुभाषिनी? So ये भी एक extra point है which you have to learn. Or one more about these light gases section, that is the radon. You have to write down one more point about the radon. Radon gas releases in environment at the time of arrival of earthquake and volcano. One more point you have to add here. Radon gas releases in environment. Radon gas releases in environment at the time of arrival of earthquake and volcano. Earthquake and volcano. So if the radon gas presence in environment or increases in environment, it indicates what kind of phenomena. It indicates कि there is a perceptions. अगर हम लोग देख ले simple सा, there is chance of volcanic eruptions or there is chance of earthquake. Okay. Now come for some next point. You can see here the composition of atmosphere. Again the same points is here. I have written. Take dry air from Earth's atmosphere contains 78.08% at the points. Here the most important point is the trace gases. We have to mark this one. Trace gases. These are the very volatile gases and found very minimum amount in atmosphere. Like you can see, the remaining gases are often referred as trace gases, among which are the greenhouse gases, the principally carbon dioxide, methane, nitrous oxide, and ozone. These are so-called the trace gases, which presence in atmosphere in a very least amount of percentage. So those referred as a trace gases. Now next, various industrial pollutants also may be present as a gases or a aerosols. Okay, such as chlorine, fluorine compounds and the elemental mercury vapor. So in environment, you can see the chlorine, fluorine and elemental mercury vapor releases through the industrial pollutants. Okay. Argon is not constituent into a light gases. Argon comes in the noble gases. Okay, Suhasini. Argon comes in the noble gases, and noble gases are light gases. Out of noble gases, the only one exceptional is the argon, which is the heavier gas, and rest of others are the light gases. You can mention here the helium. Helium यहाँ पर आप mention कर सकते हैं. Helium, neon, radon, xenon, krypton. Right? Now it is clear or not? Is it clear now? Next. So always remember the trace gases also. ठीक है, trace gases. Next one. One more point here. The permanent atmospheric gases remain in fixed proportion. That's the most important point. The fixed proportion to total gas volume. Other constituents vary in quantity from place to place and from time to time. Like you can see, just because of the urbanization and industrialization, you can see the several regions have getting some spatial changes in a proportion of gases. Like you can see the CO2 gases, methane gases, the water vapor. Okay, so the permanent atmospheric gases remain fixed in proportion, and those are also considered as a homogeneous layer. I am just explaining it later on. Okay, and other constituents vary in quantity from place to place and from time to time. Like one more point you can see here, the heavier gases like nitrogen and oxygen tend to stick at the bottom of the atmosphere, and the lighter gas you can find out where? In the upper layer of atmosphere. Okay, like you can see here. Also, what about the density of atmosphere? What do you think? Density of atmosphere. So it is more dense in lower region and it is less denser in upper region. It's just because the heavier gas are here, which having a maximum proportion like a nitrogen, oxygen, carbon dioxide and argon, and the light gases are above. So density decreases from surface to upper level. One more point you can add there in your notes. Density decreases from density of air or atmosphere decreases from surface to upper level of atmosphere. Okay. One more point we are going to see here. The proportion of gases changes in the higher layers of the atmosphere in such a way that oxygen will be almost in negligible quantity at the height of 120 km, already asked in IAS exam. It has asked in IAS exam as well as in a UPPSC. Okay. So around the 120 km, oxygen will be almost negligible. Similarly, the carbon dioxide and the water vapor are found only up to the 90 km from the surface of the earth. Okay, so some more point is coming to you. You can write down in your copy or go through these facts. You can memorize the whole concept of atmosphere. Come for the next. And the next one is water vapor. Water vapor. What do you think? Water vapor is remain constant for every place or at every height? No. It is found maximum at equator. at 0 degree. Equator line. It's just because of the temperature. Temperature is high in this region, and so the evaporation and the vaporization. And so the evaporation is high, and that's why the water vapor is maximum found on the equator line. You can write down here, maximum found in at equator, at nearby equator line. ऐसा भी कर सकते हैं, nearby equator line or at equator line. Whenever you are going from equator towards the poles, it decreases. It decreases. So you can mention one more point. The percentage of water vapor decreases from equator towards poles. Percentage of water vapor decreases from equator towards poles. Okay, towards poles. It's just because in this region you can see the temperature is low. So how the water vapor will present here? So here you can see at equator line, you can see the 4 to 5% is the water vapor. 4 to 5% of the total proportion of atmosphere. But in the region of poles, you can see the 0 to 1%. Again, in a desert region, you can see the percentage of water vapor is only the 0 to 1%. Just because of the dry region. These are the dry region. Because of the subsidence of air or a decent air, which makes the surroundings very warm or dry. Okay, so here we have seen the maximum presence of water vapor is around or nearby the equator line. It's just because the temperature is high there, and so the evaporation is also high. Or whenever we are going from equator towards the poles, the percentage of water vapor is decreasing, and it reaches till to the 0 to 1, 4 to 5% to 0 to 1%. And again the 0 to 1% is for the desert region. That is also the dry region because of the decent air. Okay, because of the subsidence of air. Getting a point? Is it clear or not about the water vapor? ईसा अम्बस्ता, बहुत बहुत स्वागत है बच्चे. Warm welcome to you. Okay, Mridulaz. So any kind of doubt you can mention here in the comment box. I will clear all doubts, because the geography is totally depends on the concept, and if your concept clear हो चुका है, then nothing is. You can rock. So water vapor is clear. Now we are coming for the solid particles. One more question arises from the UPSC IAS. Here you can see. They have asked the solid particles of the aerosols, or the name has given, you have to mark down on that question. Solid particles present in the atmosphere consist of what? Same question arises in a UPSC IAS. Consist of what? The sand particles. One more. Sand particles from weathered rocks and also derived from the volcanic ash. Weathered rocks, that is by the denudation process or a weathering process, and derived from the volcanic ash also. It also releases the solid particles. Then the pollen grains, a small organism, soot, and the ocean salts. So these were in the answer, and you have to match it. The solid particles present in the atmosphere consist of sand particles from weathered rocks and also derived from volcanic ash, and the pollen grains and the small organisms, soot and the ocean salts. The upper layers of the atmosphere may even have fragments of meteors which got burnt up in the atmosphere. Like you can see in mesosphere of atmosphere, that is the third layer or the middle layer of atmosphere, whenever a rock fragments of asteroids enters into atmosphere of Earth, but in the exosphere and the ionosphere, they are not getting burned. It's just because of the high temperature and the air molecules has separated extremely. But whenever it enters into mesosphere, and just because of the density of gases increases at that layer, just because of frictions occurs through the air molecules, it will burnt up. So the rock fragments of asteroid getting burned in mesosphere. Okay, then you can see if it totally burnt, it is called the meteors. Or if it reaches to the Earth's surface, it will call the meteorites. But what I said, if it totally burnt, it will releases the dust particles, and that is so given here. So in mesosphere, you can see the exceptional clouds, that is so called the noctilucent cloud, has formed. It's just because of the condensation process occurs over the dust particles released through these meteors. Okay, getting a point. Is it clear? पोलन ग्रेन्स के बारे में पूछा है बच्चे ने, सौम्या शेखर जी ने. सौम्या, what do you think about the pollen grains? That means this one is the microorganism or a microscopic structure. Okay. ठीक. That means one more point I want to add here for the सौम्या शेखर कि pollen grains अगर हम देखें तो एयर में जैसे कि polluted जो materials जो मिक्सअप हो जाते हैं. ओके ओके, जैसे कि like you can see the hot, dry or a windy और a stormy जो conditions बनते हैं और उसमें जो पॉल्यूटेंट्स जब ऐड अप हो जाते हैं पूरा, तो पॉलन ग्रेन्स ही तो है. और क्या है वो? वही पॉलन ग्रेन्स है ना. ओके, अब लाइक pollen grains, you can see it will impact over the your health also. It can create the allergies of your eyes, of your skin. Okay. Next we are getting here, these solid particles perform the functions of absorbing, reflecting and scattering the radiation. You can see the sky is blue, it's just because of presence of dust particles. Okay, so dust particles is responsible for the sky is blue, or it just because of what? You can see the dust particles are absorbs, reflects and the scattering of the radiation also. So like you can see how the sky becomes blue. Let's see. In the daytime, you see the sun rays coming to the earth. But the sun rays comes in a VIBGYOR, in a spectrum. VIBGYOR. And out of these 7 color, the maximum wavelength is for the red and the least wavelength is for the violet, indigo and the blue. Okay. So when it is coming towards the Earth's surface, the maximum scattering is happening for the blue. Maximum scattering is happening for the blue. Here you can see scattering. Maximum scattering is for the blue, and that's why the sky becomes a blue. So it's just because of the scattering. But again, I am going to give you some other phenomena. The solid particles are consequently responsible for the orange and the red colors at sunset and sunrise also. And for the length of dawn and the twilight. What is dawn and the twilight? So dawn is the first appearance of light in the sky before sunrise, and the twilight, the soft glowing light from the sky when the sun is below to the horizon, caused by the refraction of the sun's rays by the atmosphere. We are coming on that point, Vivek. Why the dust particles will found maximum at the subtropical regions. So first of all, we are getting the knowledge on how it happens. So have a look. Here it is the sun, and this one is earth. And the sun rays come to earth. Now the distance is far away. The distance is far, or far distance you can mention here. At the time of sunrise or sunset, the slant rays of sun rays is coming. It has to travel maximum distance, and so you can see the scattering of the blue color and other colors. Only the red color will reach to the Earth's surface. Only the red color will reach to the Earth's surface. It's just because of wavelength is high. Now you can see here in a spectrum, here it is the blue and this one is the red. And we talk about the wavelength and a frequency. Wavelength and the frequency. So you can see here the blue having a low wavelength and a high frequency, but the red having a high wavelength or a low frequency. Okay. So red color reaches to the Earth's surface at the time of dawn or a twilight. It's just because of wavelength is higher regarding the others. Okay, so why the reddish color present in atmosphere at the time of dawn and the twilight? You have to remember this concept, because the red color having a maximum wavelength, so this will reach only at the Earth's surface, and so it appears reddish in color. Okay. Next we are some more point about the dawn, about the twilight, about the dusk. Dusk is what? The darker stage of twilight. The darker stage of twilight is also called the dusk. Take here one more point you can see here. The blue color of the sky is also due to selective scattering by dust particles. We have already discussed it. Some of the dust particles are hygroscopic. Most important point. Some of the dust particles are hygroscopic. You can mention it, the dust particles are referred as a hygroscopic nuclei because a condensation process occurs over the hygroscopic nuclei. So here you can see the some of the dust particles are hygroscopic, readily absorbing moisture from air. That means hygroscopic. What do you mean by the hygroscopic? It absorbs the moisture from the air. It absorbs the moisture from the air in a readily absorbing way. In character and as such act as a nuclei of condensation, and thus dust particles are an important contributory factor in the formation of clouds and different forms of precipitation like a fog, hailstorm, haze, etc. Okay, so dust particles is very important. Like a question has arisen in a UPSC कि precipitation occurs through what? First of all, and the most responsible factor about it क्या? तो वो था dust particles, धूलकण जिसको आप कहते हैं. सबसे ज्यादा जरूरी है, most important factor है which over the condensation will occur. Without the dust particles, condensation process can't occur and there can't be formation of clouds and there can't be precipitation. Okay. Then one more point about the what Vivek Kumar has asked. Let's see. Why the dust particles are maximum present in a subtropical region? Why the dust particles are maximum present in the subtropical region? Here it is the 0-degree equator line. And now you can see it has maximum, directly you can mention the dust particles. (20 to 30 degree is the subtropical zone basically. Or here you can see the maximum presence of dust particles. Because of less rainfall, decent air, friction through horizontal winds, now you can see at equator line there is a maximum precipitation or a maximum rainfall, or simply you can mention the full year rainfall. That will be more correct. Full year rainfall. Or if rainfall occurs maximum in those regions, how can a dust particle sustain in the atmosphere when it will be soluble in water and it will reach down to the earth's surface? Okay. So what do you think ki in a subtropical region, that environments gives a conditions in which the maximum dust particles will occur because of the less rainfall, decent air and the friction through the horizontal winds. Is it clear? शुभम शर्मा जी का बहुत बहुत स्वागत है. So you must like and share these videos because we have started our English medium Exampur IAS platform also. And also we will try our best to give a concept clarity based classes on this platform. Our team is here, in which you can see, I am not recalling the name of the two ma'ams, but they are providing the history classes and the economy classes, and Apu sir is giving the current affairs class. Tosif sir giving the CSET classes. Okay. Kausik Pandey ji, warm welcome to you, brother. So इस चैनल को भी हम लोग को आगे लेकर चलना है, कोशिश करेंगे. और अभी तक जो क्लासेस चल रही थी, जैसे बाइलिंगुअल क्लासेस हम लोग प्रोवाइड करते हैं, मैक्सिमम बच्चे जो हमारे साथ में जुड़े हुए हैं हिंदी मीडियम के ही होते हैं, बट इंग्लिश मीडियम के बच्चों को भी थोड़ा सा लर्न करना है. मैं अगर लिटरली बताऊं तो एग्जाम्पुर में पिछले लास्ट 1 ईयर से लगभग मैं क्लास ले रहा हूं. सो अर्लियर आई वाज फोकस्ड ऑन इंग्लिश sentences or explanations, but from the last 1 year I have switched to Hindi medium, totally Hindi medium, and I am writing Hindi on board. So very soon we will cover it also. So dust particles is maximum presence in the 20-30 degree subtropical region because of these factors. Also here it is dry winds. In this region you can't see the humid winds. Dry winds is there. ठीक है. धीरे धीरे चीजें क्लियर होंगी और कोशिश मेरी है कि कंटेंट पर फोकस मेनली करना है. आपको कंसेप्ट पर फोकस करने की जरूरत, जो भी मैं कंसेप्ट आपको बताता चल रहा हूं. सो वी कैन कवर इट अप. नाउ you can see here the May 2015 question. How far do we agree that the behavior of the Indian monsoon has been changing due to humanizing landscapes? So the increasing rate of the urbanization and the process through the industrialization, we release maximum pollutants. So just because of that, you can see in a urban area and a rural area. Urban area faces intense rainfall, while rural area having a scanty rainfall. Why? This question demands only these two factors. So just we have learned कि if we releases maximum amount of the dust particles or the pollutants, it will works as a hygroscopic nuclei, which over the condensation process will occurs more, and it will absorb the maximum moisture of the atmosphere, and it produces the intense rainfall. So you can see the spatial changes in a region of a place. In an urban region, there is an intense rainfall. In the rural areas, you can see the scanty rainfall. Getting a point? It happens because of the dust particles increasing in the environment. And also the water vapor. Yeah, generally Mahima Tyagi ji, definitely. Urban region works as a heat island. You can see here, it works as a heat island. ठीक है? And so it's just because of the deforestation, and the industries are going rapidly day by day, and also the concrete roads are there, and the high skyscrapers are there, which stops the terrestrial radiation which is emitting from the Earth's surface to the space. So it absorbs the maximum heat and becomes a heat island. Okay, so here you can see the some explanation. I have mentioned it here. High concentration of condensation nuclei disrupts regional patterns of Indian monsoons. Now you can see the increase in the number of condensation nuclei. ध्यान दीजिएगा. Number of condensation nuclei due to increased availability of pollutants and dust particles. It will also increase condensation of water vapor, what I have said earlier. Same point is given here. Increase in the number of condensation nuclei. That means the number of condensation nuclei what? That is increase of the dust particles, which acts as a hygroscopic nuclei. And due to this increased availability of pollutants and dust particles will increase condensation of water vapor, and this phenomena occurs in a urban region. अब ये किस में है तो urban region में. ठीक. Next again you can see that as the urban atmosphere tends to have greater concentration of condensation nuclei due to vehicular pollution and construction activity, the monsoonal rainfalls is disproportionately high in the urban areas. So now you can see whatever we have just discussed, this is given in sentence. As a consequence, the agriculture dependent rural areas tend to receive disproportionately low rainfall. It's just because of the less amount of hygroscopic nuclei. So if the hygroscopic nuclei as dust particles increases in any region, what do you think? It provokes maximum rainfall. Okay, so hope you all are getting it. Now we are shifting from composition of atmosphere to a structure or a stratification of atmosphere. So now you can see the next topic is the structure or stratification of atmosphere. Here you can see the layers of atmosphere from the Earth's surface. This one is the Earth's surface. The first layer is troposphere. Second one is stratosphere. Third one is mesosphere. Fourth one is thermosphere and the exosphere. Beyond it, you can see the magnetic or a magnetosphere is also. Okay. Beyond it, we can see the magnetosphere is also there. We will learn it later on. Okay. So one by one, we will get some knowledge about these layers, and then we will proceed. Right? So come. So first of all, we have to mention what? The troposphere. Sometimes questions arise through the layers of the lower region or a upper region also. So remember it. Okay. So first of all, we are getting some knowledge about the troposphere. What about the altitude of troposphere? Firstly, can you mention it on a comments box? What about the altitude of troposphere? What do you think? Height of troposphere. Simply, height of troposphere or altitude of troposphere. In Hindi, it is so called the Tungta. हिंदी वाले बच्चे ऐसे ही बेहोश होते हैं, तुंगता लिख देते हैं, बेहोश हो जाते हैं. इंग्लिश मीडियम में एल्टीट्यूड चलता है. So first of all, we are getting knowledge about the altitude. Altitude. In normal way, we see the 15 kilometer. I can okay, no, so like this. We have to show the 5 layers of atmosphere. Here it is. The first one, this one is the altitude. Altitude, here it is the 0 kilometer from the sea level, 15 kilometer, 50 kilometer, 80 kilometer, 640 kilometer and the 1000 kilometer. Beyond it, also there is a slightly existing of atmosphere till the 10,000 kilometer, and it will merge in a solar atmosphere by 80,000 kilometers. Yes, sure, Soumya Sekharji. Hygroscopic nuclei, dust particles is considered as a hygroscopic nuclei because those particles will absorb the moisture from the atmosphere, and so it is considered as a hygroscopic nuclei. Mahima Tyagi has given the 8 km, Mradul Raj 10 km, Suhasini 0 to 15 km, Vivek Kumar average height is the 16 km, Kaushik Pandey 8 to 14. Okay, let's see. Have a look. So here we are seeing the altitude of atmosphere, and again you can see here the temperature. In this side, in the X zone, you can see the temperature, in the Y zone you can see the altitude. So here we can mention it the 0 degrees Celsius, and this side plus, and this side minus. Minus 90 degrees Celsius is required, and this side it will 100, it will 200, and so on. इधर की तरफ plus temperature, इधर की तरफ minus temperature. Okay. The first layer is the troposphere. Okay, the first layer is the troposphere, and we are going to discuss first of all the altitude about the troposphere. So altitude about the troposphere is the average is the 15 km, 0 to 15 km. This is given by the Subhasini. Very nice. In some books you can see the 0 to 14 km has given, but we are following the Stoller and the Savinder Singh. This is very famous in the UPSC exam. So we will go through those two books. So here we can see the average is the 0 to 15 km. But what about the changes through the changes of latitude? So here we can see. Here it is the 0 degree equator line. 0 degree equator line, and this one is the pole. Now you see at the equator line temperature is high. Temperature is high, and at the polar temperature is low. Right? Temperature is low. So what will happen just because of the variations of temperature? Now you can see if this is a equator line or a zone of the 5 to 5 degree, mention it, no issue, 5 degree north to 5 degree south. It's just because of the direct rays of the sun and the perpendicular rays of the sun. This region will get intense heat and becomes the warm surface. So the surface is hot. Now the surface is hot because of the full year perpendicular rays of the sun, direct rays of the sun, almost full year, direct rays of the sun. And so why this region becomes much hotter? Because the sun rays has to travel less distance. So shorter the distance, maximum the heat received by the second law of thermodynamics. Getting a point? Shorter the distance, maximum the heat received by the second law of thermodynamics. This gives this explanation. That means the maximum heat received to this place, so temperature becomes high. And temperature becomes high, the surface becomes warm or hot. And so the surrounding air of this surface also becomes warm. Now you see the air is warm. It's because of what? Which process? The process is so called the conduction process. Process is so called the conduction process, by which the heat transfer from one layer to another layer. And that is so called the conduction process. Okay. So through the conduction process, so air becomes warm also, and because of the intense heat, surface is already heated. And when the air becomes warm, it will becomes unstable or light. It will becomes unstable or a light air. Okay. And when it becomes unstable, it will move upwards. and now you see the air is moving upwards. And these upwards moving air is so called what? Convective currents. This one is calling what? Convective current. And just because of this convective currents, the height of or altitude of troposphere is maximum at equator line, and that is 18 kilometer. That is 18 kilometer. Getting a point? Ki just because of the high temperature in this zone, due to full year direct rays of sun comes to this region, and just because of the short distance covered to sun rays, it will provides maximum heat, so the surface becomes warm, and through the conduction process air becomes warm, air becomes unstable and becomes a light air. It will move upwards, and those upwards moving air is so called the convective currents. And just because of these convective currents, the maximum altitude of troposphere is at equator line, that is the 18 kilometer. Okay. Again you can see here it is the pole, and pole having a very low temperature, and just because of the surface is low, the air becomes cold, cold air becomes the heavier, and heavier air getting what? Downwards. Okay, just because of the gravitational force more works on that air. So here you can see descending air, and here it is the ascending air. Okay, so here it is, you can see only the 8 kilometer, that is minimum. So the altitude, you can write down one more point here. Altitude of troposphere is maximum 18 kilometer at equator line, and minimum 8 kilometer at poles. And minimum 8 kilometer at poles. Clear point? And minimum 8 kilometer at poles. Okay. And it happens because of the variations of temperature. Just because of variations of temperature. Nothing else. Right? So have you got it or not? Why? I am coming on that point, Soumya. Coming on that point. Is it clear or not why the altitude is having more higher in a equator line and the lesser in a poles region? सागर सब मोह माया है. मैं भी अगर मैं आपको फैक्ट्स बताऊं तो I have taken several classes of Northeast and the South Indian students, in which I have to speak totally English in front of those students. I am talking about the offline classes, because they are not getting the Hindi. Okay, so we are trying our best to explain all things in English. My concepts are good, contents are best, no doubt, but my English is not so much good. But I am trying my best. At that time, in 2015 or 2016, at the time of, in some several classes, I have given the English medium classes, or I was from the Hindi medium, but I try my best, or I have given best content to those students, and they are totally admire me. It's a very nice, very nice. बाद में आके मतलब इंग्लिश सीखना भी शुरू किया था और बढ़िया किया. I have appeared for my mains in a Hindi medium. Centrifugal force is also responsible for tropospheric equator. Vivek Kumar, what do you think? Just because of the maximum bulge at the equator line, okay, there is a centripetal or a centrifugal force, but you can't correlate the centrifugal force for the altitude there. ठीक है, दैट्स सो मच the most important reason is for the temperature, nothing else. Okay, so do like and share also for this event. We will continue it. My timing would be the 11 to 1 p.m. for Monday, Tuesday and Wednesday. Okay, Monday, Tuesday और Wednesday मेरी टाइमिंग इस चैनल पे रहेगी आप लोगों को 11 से 1 PM का स्लॉट मुझे दिया गया है 3 दिन के लिए, ठीक है। तो ये नो, आई विल ट्राई माई बेस्ट टू टोटली एक्सप्लेन इन इंग्लिश सौम्या, और आई कैन ओके several friends of mine which is taking classes in several reputed coaching, आप सब लोग नाम जानते होंगे उन कोचिंग के, उसमें काम करते हैं, बहुत ही शानदार। अब मैं तो हिंदी मीडियम से था, इंग्लिश मीडियम से था नहीं, लेकिन मैंने वर्क किया हुआ है और मैंने इंग्लिश में स्टोनर के बुक्स को पढ़ा हुआ है, सविंदर सिंह की बुक्स को पढ़ा, मतलब हिंदी इंग्लिश दोनों के बुक्स को पढ़ता था। तो जो भी कंटेंट और कंसेप्ट में कभी कोई हिंदी इंग्लिश में गड़बड़ नहीं होता, बट स्पोकन कई बार थोड़ा इतना बेस्ट नहीं रहता है, और बाकी तो सब मोहमाया है ही। आई आगे चलते हैं, कहाँ थे हम लोग? तो ये पॉइंट आपको मैंने कंप्लीट कर दिया कि एल्टीट्यूड के बारे में। देन व्हाट अबाउट द टेम्परेचर? नाउ वी आर कमिंग टू द टेम्परेचर। फर्स्ट ऑफ ऑल, कैन यू गिव द आइडिया कि व्हाट अबाउट द एवरेज टेम्परेचर ऑफ द अर्थ? बताइए, एवरेज टेम्परेचर ऑफ द अर्थ, पॉइंट्स क्या होंगे इसके? एवरेज टेम्परेचर ऑफ द अर्थ क्या होगा? Subhasini, that is a very good sign to you, and I appreciate your efforts. We have to learn. What I say कि my children are studying in an English medium school, and they are much fluent in English than me. Even जो मेरी भतीजी लोग हैं वो सब तो जीडी गोयनका में पढ़ती है, इतनी अच्छा इंग्लिश है सबकी, मतलब मैं बोल भी नहीं सकता उस तरह से। तो इंग्लिश आज की डेट में क्या नहीं, तो नेहरू की गलती है और कुछ नहीं है, सब मोहमाया है। वे देश हिंदी भाषी था, उसको इंग्लिश से बना के चला गया। अब देखो यूपीएससी वाले में भी आप देखिए कि हिंदी मीडियम के बच्चों का सिलेक्शन अगर नहीं हो पाता है, जस्ट बिकॉज दे आर रिजिड टू ओनली लर्न इन अ हिंदी मीडियम। जस्ट ट्राई समथिंग डिफरेंट। When I got this opportunity to teach on this channel in an English medium, then I will try my best to explain the whole things in English, and I can do and I will do in a very coming days. You can see. Okay. 20 से 30 डिग्री, अबे इतना कहा है रे महिमा? कौशिक 13.9 DG, सौम्या 37, विवेक कुमार 25। मतलब कि एक तो समझ में आ गया कि तुम लोगों ने ये पढ़ा नहीं है। Have you ever learned this topic earlier? Soumya, you are from the Sarthak batch, so you must know the average temperature of the earth. That is the how much? 15 degrees Celsius. अरे 27 डिग्री रूम टेम्परेचर नहीं चलना रही, 15 डिग्री सेल्सियस। ओनली द 15 डिग्री सेल्सियस। 2500 में कहा चले पूरा ब्रह्मांड उड़ा दो कि क्या यहाँ पे हूं? ऐसे थोड़ी ना होगा। बताओ जरा सा, ये देखिए 40 डिग्री पहुंचो। अरे एक बार बताओ सौम्या, तुम्हारे बैच में क्लाइमेटोलॉजी हो चुका है, उजैर सर पढ़ा चुके हैं, तो एवरेज टेम्परेचर ऑफ अर्थ तो आपने लिखा ही होगा। अब ये भावनाओं में सब बह गया, टेम्परेचर नहीं पड़ा, कोई बात नहीं, आइए देखते हैं। Here you can see, हम लोग यहाँ पर ये दिखा रहे हैं 10 डिग्री है, ये 20 डिग्री है, ये 30 डिग्री है, एंड सो ऑन। सो वी विल चूज इट द मीडियम पॉइंट, दैट इज द 15 डिग्री सेल्सियस। here it is the 15 degrees Celsius. And now we are going to take, what about the temperature when we are going away from the Earth's surface? Sochiye. So now we can see the temperature decreases with increasing altitude. Temperature decreases from increasing altitude. So next point you have to mention in your copy or in your mind. Next point रहेगा temperature decreases with increasing altitude. And what about the rate by which the temperature decreases? Mradul Raj, my classes would be totally based on a concept clarity based classes, brother. Okay, once you learned it, you will always be able to solve the all kind of questions, whether it is arise in a UPSC or some other state PCS or a UPSC. ठीक है? So I always try my best to give the basics as well as the advanced level. So temperature decreases with increasing altitude. How? Let's have a look. Like ki there is a Burj Khalifa. Like there is a Burj Khalifa. And the height of Burj Khalifa, you can know the 8 to 8 meter. So much high. So when you are going upwards, the air expands. What is happening? Air expands. And whenever the object expands, it releases temperature. And the volume increases and the air expands. तो सिंपली आपने पढ़ा भी होगा कि जब भी कोई वस्तु फैलती है तो उसका टेम्परेचर कम होता है. When the object expands, the temperature decreases. So what about the rate in a normal condition? सामान्य दशा, normal condition की बात करें. So this one is the NLR or the ELR. NLR or ELR, the full form of NLR or ELR is the normal or environmental lapse rate. And what about the rate? That is the 6.5 degrees Celsius per 1000 meter or a 1 degree Celsius per 165 meter. So yeah, that's a good thing. The temperature decreases from equator to poles. That's good. But we are talking about the troposphere right now. In troposphere, temperature decreases with increasing altitude. It's just because of the air expands and becomes cools. And the rate by which the temperature decreases, that is the normal or environmental lapse rate, and the rate is the 6.5 degrees Celsius per 1000 meter or 1 degree Celsius per 165 meter. Okay. So I will complete the whole GC Leong also as well as the NCRT, and my concept is with you also. सृष्टि सैनी कहाँ पे नहीं चल रही है बहू? बिहार पे आज मैं चलता हूँ, ठीक है, हम लेंगे कल. So in English, I will take class tomorrow in Bihar channel. फाइव आवर्स की कल चलेगी, मजा लेना पूरा. So at least you must or you have to do like or subscribe this channel also, and share if you want to share. देखिए, so here it is clear the temperature decreases with increasing altitude. One more point, that is all weather phenomena occurs in troposphere. All weather phenomenon occurs in troposphere. अब पॉइंट यहां पर ध्यान रखिएगा, what kind of phenomena? तो clouds, fog, mist, जो भी आपका पसंदीदा उसको लिख लीजिए, साइक्लोन, storms, anyone, rainfall, etc. It's just because four process: radiation, conduction, convection, and advection. Subhasini, most probably my class will be air at 8 a.m. morning or otherwise 10 a.m. morning on Bihar channel tomorrow. पायल जी का बहुत बहुत स्वागत है बच्चे। जो ही बच्चे आज जुड़ रहे हैं, मैं आपको बताना चाहूंगा कि मंडे, ट्यूसडे एंड वेडनेसडे को ये क्लासेस मेरी चला करेंगी। कंसेप्ट क्लैरिटी बेस्ड क्लासेस होंगी। आई विल ट्राई माय बेस्ट टू डू ऑल थिंग्स इन इंग्लिश वे। ओके, also I have to enhance my English skills and I will try my best. So all weather phenomena occurs in the troposphere. One more thing, this layer is so called the friction layer. This layer is so called the friction layer or a convection layer. One more point you have to add here. This layer is referred as friction layer and convection layer. What do you think about the friction layer? It's just because of the winds blowing in this troposphere. Because of winds, blowing of winds. And it's happening just because of the convection process. Western disturbances क्या होता है? I will definitely explain, Soumya. Western disturbances is nothing, that is the Westerlies Winds. Okay, Westerlies Winds. It's just because of the southwards movements of the sun. The subtropical high pressure belt of the north hemisphere comes down to the 20° north latitude, and just because of this shifting of pressure belts, the westerlies winds which blows above the 35° in the north hemisphere, it comes to the 25° north latitude, and now it is blowing above the Mediterranean Sea and collects the moisture and it produces rainfall moving further. So the precipitation occurs in a western disturbances, that is nothing, that is comes through the westerlies winds. It carries moisture from Mediterranean Sea, and with the effect of jet stream, you have to add jet stream phenomena in western disturbances. Several times I have seen ki no one is giving the jet stream phenomena in a western disturbances, but in a UPSC you have to learn it. I will explain it in our monsoon section, definitely in Sarthak batch. Okay, Soumya. Srishti, I can't provide my phone number, sister. You can follow me everywhere. I am present with the name of Aman Arjun Sinha. So, this layer is referred as a friction layer and a convection layer. Both points you should remember. Okay, now we are coming for the tropopause. Now we are coming for the tropopause. Let's have a look. Where is tropopause? You can see here कि we have mentioned the 0 to 14 kilometer is the troposphere. This is the troposphere. ये ट्रोपो है, ये स्ट्रेटोस्फीयर है, ये मीजो है, इसको हम लोग आयनो कह देते हैं और थर्मो करते हैं और इसको हम लोग एक्सो कह देते हैं. These are the layers ना. So, अच्छा, one more point I want to add here. See, what about the minimum temperature found in troposphere? Anyone can explain? Minimum temperature found in atmosphere. Temperature decreases. Anyone can give the answer? Minimum temperature of troposphere is how much? BPSC भी क्रैक होगा सृष्टि तुम्हारा, एंड यू विल डेफिनेटली क्रैक यूपीएससी. मेहनत करने से सब कुछ होता है, क्यों नहीं कर सकते हैं? बताइए. What about the minimum temperature of atmosphere and where it is found? Must know. That is the -10 महिमा त्यागी. Okay. अभी मैं देखता हूँ. Yes, this one. So earlier we have seen the temperature decreases with increasing altitude. Clear है? Now come. See, here it is the equator line and this one is the poles. Okay. So temperature is high at which place? Equator line. So just because of the temperature is high, the air moves upwards till the 18 kilometer. Now you see 18 kilometer. And here altitude of troposphere is only the 8 kilometer. First point. You have to mention minimum temperature of troposphere. Minimum temperature of troposphere is minus 60 degrees Celsius. Is minus 60 degrees Celsius at equator line. Without of sound knowledge, you will always mark it is the minimum temperature of troposphere. It would be where? The poles. But the right one is at equator line. How? That is the concept. That is the concept. That's a very good sign. Comes from the Subhasini Suryavanshi, the minus 60 degrees Celsius at equator. बहुत ही शानदार. Pulse 8 kilometer है पायल. बहुत बढ़िया बच्चे. Your name is so nice, like Subhasini. Payal Kahal. Okay, good. Mradul Raj. Great. Let's see. Temperature decreases with normal lapse rate. and that is the 6.5 degrees Celsius per 1000 meter. So simply 18 cross 6.5 degrees Celsius, and here it is the 8 cross 6.5 degrees Celsius. Simply. If the temperature of this place about the 30 to 35 degree maximum, because its variation is very less because of the full year rainfall or a full year heat comes from the sun. So the temperature you can see here at least around अराउंड में 110 डिग्री सेल्सियस हो रहा है, और अगर सरफेस टेम्परेचर यहाँ पर -35 डिग्री भी कर लेंगे तो अराउंड में आप देखेंगे कि 70 डिग्री के आसपास में यहाँ पर लगभग आपको देखने को मिलता है. बट यही चीज होता है कि मिनिमम टेम्परेचर ऑफ ट्रोपोस्फेयर इज -60 डिग्री सेल्सियस एट इक्वेटर लाइन. यही बनाया गया हुआ है, ये आपको स्टॉलर के बुक्स हो या फिर सविंदर सिंह के बुक्स हो, यही आपको मिलेगा. यहाँ पर देखिए आपको अगर हम लोग देखते हैं कि अराउंड में 50 डिग्री सेल्सियस यहाँ पर आपका माइनस में जाता हुआ दिख रहा है. अगर ये 0 है तब भी -50 ही रहेगा, बहुत ज्यादा कम यहाँ पर नहीं होता. सो द मिनिमम टेम्परेचर इज एट इक्वेटर लाइन इन ट्रोपोस्फेयर. ध्यान रखना, ये क्वेश्चन बनते हैं यहाँ से, कंसेप्ट को ध्यान रखिएगा. ठीक है कि ट्रोपोस्फेयर का मिनिमम टेम्परेचर जो है वो कहां पर है, तो वो आपको पोल्स पर नहीं होता, वो आपको इक्वेटर लाइन पर होता है. ओके, नाउ वी आर कमिंग फॉर व्हाट, ट्रोपोपॉज. नाउ यू सी द ट्रोपोपॉज. ट्रोपोपॉज थिकनेस is 15 to 20 kilometer. That means the 5 kilometer. What is it? So it is transition zone between troposphere and stratosphere. Again, temperature remain constant. Temperature remain constant in this layer. So that is the all 3 points of the tropopause. What is it? This one is the pause where the let's see. This one is a transition zone between troposphere and stratosphere. So you can see the troposphere, the temperature decreases. In troposphere, temperature decreases, while in stratosphere, temperature increases. So this one is the transition zone where the temperature remain constant. That means कि 15 or 20. So temperature will also remain -60 degrees Celsius at this region. Okay. So 15 to 20 kilometer temperature remain constant, and this zone is referred as a pause. Earlier it was assumed as a stratosphere because of the temperature is constant, but later on and nowadays we know in a stratosphere temperature increases with increasing altitude because the ultraviolet rays of sun absorbs by the ozone gas presence in this layer. Got it or not? Clear है? So now we are moving for the stratosphere. Like you see here, in troposphere you can see the temperature decreases from the 15 degrees Celsius. Here it is. Tick. Temperature decreases, temperature remain constant. Temperature increases, temperature remain constant. Temperature decreases, remain constant, and the increasing rate of temperature. So in this picture, even the layers of atmosphere, sometimes if the question asked layers of atmosphere based on what? And then it is based on changes of temperature. It is based on changes of temperature. तापमान के आधार पर ही एटमॉस्फेयर के लेयर का डिवीजन किया गया होगा. सो डिवीजन ऑफ एटमॉस्फेयर इज बेस्ड ऑन टेम्परेचर. ये भी ध्यान में रखना. डिवीजन ऑफ एटमॉस्फेयर इज बेस्ड ऑन टेम्परेचर. होप यू ऑल आर गेटिंग. एंड थोड़ा इस चैनल को सभी लोग सपोर्ट भी किया कीजिए. मेरी जो क्लास की टाइमिंग होगी 11 से 1 बजे मंडे ट्यूसडे वेंसडे में. आज फ्राइडे है, क्योंकि आज पहली क्लास लगनी थी इसलिए आज भी मैं ले रहा हूं यहां पर. अदरवाइज आई विल टेक क्लास ऑन मंडे ट्यूसडे वेंसडे एट 11 to 1 PM. So is it clear? The layers of atmosphere is based on temperature. In troposphere, temperature decreases. In stratosphere, temperature increases. In mesosphere, temperature decreases. Or in the ionosphere and the exosphere, temperature regularly increases. So why there is only the 3 pause has given. Here you can see the 3 pause: tropopause, stratopause, and the mesopause is there only. Why not the ionopause or a thermopause? Why not? It's just because in a thermosphere or a ionosphere and exosphere, temperature gradually increasing. So there can't be a transition zone. In this region you can see the temperature decreases, temperature increases. So there should be a transition zone. Temperature increases, temperature decreases. There should be a transition zone. Temperature decreases, temperature increases. There should be a transition zone. So that's why there is only the 3 pause region or 3 transition zone: tropopause, stratopause, and a mesopause. Clear है? Okay. Is it clear to you all? Everything, every concept should be crystal clear. If question arise from this part, you should be able to give answer. Now come to the इसको उठा के ऊपर करना होगा. आइए नेक्स्ट वन इज द स्ट्रेटोस्फीयर. Next one is the stratosphere. And what about the thickness of a stratosphere? Why it is so called the stratosphere? Only the 3 transition zone is there. बिल्कुल great. मृदुल राज, सुभाषनी, पायल, सौम्या. Let's see. A stratosphere. The first point about this layer is temperature increases with increasing altitude. Temperature increases with increasing altitude and the rate is 5 degrees Celsius per kilometer. Because ultraviolet rays of sun absorbs by ozone gas presence in this layer. Okay, ozone gas presence in this layer. ठीक है. Yeah, normal lapse rate is only applicable in a troposphere, Soumya. Great, very nice. So it is called ozonosphere too. ठीक है. And Okay, Mradul Raj, let's see. This one is a stratosphere. So a stratosphere 20 to 50 kilometer is there, but including the transition zone, we can say it from the 15 to 55 kilometer. Here it is. ये है 15 से 20, 50 to 55 kilometer. Okay, let's see. So in a stratosphere, we see the temperature increases. Rate क्या है? 5 degree Celsius per kilometer, or it is called ozonosphere. Up now you see the ozonosphere. This one is 15. Here it is 20, 50, and here it is the 55 kilometer. Now you see the thickness or altitude of ozonosphere is 15 to 55 kilometer. 15 to 55 kilometer is the thickness of ozonosphere. 15 to 55 kilometer is the thickness of ozonosphere. Sumit Tiwari has given the accurate point. Just perfect. Mradul Raj, definitely it's just because the ozone gas presence from the 15 to 55 kilometer. So that's why the ozonosphere is totally considered as a 15 to 55 kilometer. But if the question arises like this, the maximum concentration of ozone gas. If question arises like this, maximum concentration of ozone gas, and that is presence in a 20 to 35 kilometer. That is presence in the 20 to 35 kilometer. So we are getting knowledge about the ozonosphere here. Ozonosphere, the thickness is the 15 to 55 kilometer, and the maximum concentration of ozone gas is the 20 to 35 kilometer. In a stratosphere, temperature increases with increasing altitude because the UV rays of sun absorbed by the ozone gas presence in the layer. What about the rate? The rate is the 5 degrees Celsius per kilometer. And in this zone or in this layer, weather phenomena doesn't occur. And so, exceptionally, a nacreous cloud or a mother of pearl can form in this region. This layer is most suitable to fly the jet planes. Most suitable to fly the jet plane. I have given this in a इस point पे देखते हैं. Like if you see the ozonosphere, it lies at an altitude between the 15 kilometer and the 55 kilometer from the Earth's surface, and spans the stratosphere and lower mesosphere, but the highest concentration occurs between the 20 to 35 kilometer. It has given in a sentence. Next, because of the presence of ozone molecules, this layer absorbs and reflects the harmful ultraviolet radiation. ये भी हो गया. The temperature rises, जो NLR की चर्चा हुई थी, the temperature rises negative lapse rate at a rate of 5 degrees Celsius per kilometer through the ozonosphere. So in ozonosphere, what about the rate of increasing temperature? That is the 5 degrees Celsius per kilometer. Why here it is given the negative lapse rate? Negative lapse rate because temperature gone in a negative way. ठीक. Next, the ozonosphere is also called the chemosphere. The one more point or the important point is here. ozonosphere is called as a chemosphere because of a lot of chemical activity taking place. Okay, ultraviolet light splits oxygen into individual oxygen atoms. So I am giving a chemical reaction here. Ki just in the presence of sun rays, oxygen gas divides in a single oxygen molecules. The atomic oxygen then combines with unbroken oxygen to create ozone. So how the ozone creates in ozonosphere? So reaction is like this. O2 in the presence of sun rays or sunlight, O plus O, and in the next phase you see O2 plus O becomes a O3. ओके, देखिए इसको ऐसे बना लीजिए और इसको भी ऐसे बना लीजिए. Let's see. So this is the chemical reaction happening in a stratosphere. So the stratosphere or a ozonosphere is considered as a chemosphere. So chemosphere रसायन मंडल, इसको कभी अगर ऐसे भी आ जाए chemosphere रसायन मंडल. So remember it. Okay. The ozone molecule is unstable, although in the stratosphere, long-lived, and when ultraviolet light hits ozone, it splits into a molecule of oxygen and an individual atom of oxygen. So this one is the ozone-oxygen cycle. Most important point, this one is the ozone-oxygen cycle. Getting a point? Ozone-oxygen cycle. Clear है? Next. Stratospheric ozone depletion. One more important point. Stratospheric ozone depletion is caused by chlorofluorocarbons, CFC gases. It releases through the AC, refrigerator and some other substances. So chlorofluorocarbons, bromofluorocarbons and other ozone depleting substances that increase the concentration of chlorine and bromine radicals. Okay. So these three slides you also have to remember. Then again we are coming for this point, and jet planes. One more point you have to add in a stratosphere. Jet planes are flies in a stratosphere. Because of optimum condition. Because of optimum condition. Then one more point. Like we just explained it, there can't be a weather phenomena occurs in a stratosphere. But somehow a cloud can form in this region. Like see, exceptionally nacreous cloud or mother of pearl can form in this zone or can form in a stratosphere. But the most important point, how the nacreous cloud will form. How the nacreous cloud will form. So have a look. How can this clouds can be formed in this zone? No, there is not a horizontal winds blows in a stratosphere. Horizontal winds only blows in a troposphere, and so the troposphere is referred as a friction layer. We have just learned it. Vivek Kumar, Have you got it or not? Clear है? Horizontal winds only blows in a troposphere. How can it blows in a stratosphere? There can't be a situation or a conditions like in which there is a high pressure and a low pressure creates in a stratosphere. Okay, so let's see how the mother of pearl or nacreous cloud formed. Let's see, the temperature is high and so the air becomes warm because of the hot surface. When the air becomes warm and it continues for several days, and here you can see air move upwards. Air move upwards, and here it is the बीस 15 kilometer, 15 kilometer. This one is the stratosphere. Okay, so you can see the convective currents from the troposphere. This one is the convective currents in troposphere having intrusion in a stratosphere and thus formation of mother of pearl or a nacreous cloud. How the intrusion of convective currents in a stratosphere? So it will carry the water vapor and it introduces dust particles into a stratosphere. Without the dust particles, condensation process can't access or clouds can't be formed. So just because of these convective currents, the dust particles and the water vapor are reached to the stratosphere and thus forms a nacreous cloud. This one is so called the nacreous cloud, but rainfall can't occur through these clouds because of the lack of water vapor. Take nacreous cloud, or this one is also called the mother of pearl. This one is also called the mother of pearl. So mother of pearl or a nacreous cloud forms in a stratosphere because of intrusion of convective currents from the troposphere. Okay. Got it? You have listened about the jet stream, Vivek. Not the horizontal winds blows in a stratosphere. If the horizontal winds blows in a stratosphere, how could you place the jet planes? Even you can see the aeroplane is flies in a stratosphere. ठीक है? So today we have to wind up our class just because of other faculties are coming for this studio, or we will meet again at Monday, Tuesday, Wednesday, 3 consecutive days we will take classes, or then in next class we will learn about the mesosphere. There is the phenomena about the noctilucent cloud, then the ionosphere, then the exosphere, and also I have given the significance. You should must importance of Earth's atmosphere. आप सब इसका स्क्रीन so ये I will provide the PDF on Exampur official application. So you should download it from Exampur official application. Okay. So आज की क्लास को यहीं तक रखते हैं. Polar jet and subtropical jet, that is only blows in a troposphere, विवेक कुमार. ठीक है. Jet streams जो होते हैं, that is only blows in a ट्रोपोस्फीयर, नॉट इन स्ट्रेटोस्फीयर। अगर कहीं पढ़े होंगे तो उसको सही कर लेंगे, ठीक है, उसको सही कर लीजिएगा, हो जाएगा सही, नेक्स्ट क्लास में सही करवा दूंगा, ठीक है। सो आज के लिए इतना ही, फिर आप लोगों से मुलाकात होगी, और इस चैनल को लाइक और सब्सक्राइब करके जरूर रखिएगा, और अगर आपको ये क्लास अच्छी लगी हो तो इसको शेयर भी कर सकते हैं अपने दोस्त यार में, जो इंग्लिश मीडियम के बच्चे होंगे उन तक आप इसको जरूर पहुंचा सकते हैं। मिलते हैं नेक्स्ट क्लास में मंडे को आप लोगों से, तब तक के लिए नमस्कार, धन्यवाद।